Then in your WebAssign, for those that maybe have done some of the WebAssign, I know there actually is a question that involves equilateral triangles. So depending on how this one goes, if you haven't done that one yet, that might allow you to get a little extra practice. So we can talk about a couple ways you could do this one. Anyways, give it a shot.
On the website, I had to do crux never. It was like, and there was a root 3 or a root 2. No root 2 on it.
I don't know. You can check.
Oops.
You guys okay with that picture?
Oh, that's a fantastic picture.
I used all the straight line feature, helps a lot. About a 30, 60, 90? You're saying root 3s and 2s, so.
Yeah. It's 1, 1, 1. We're trying to make right angles find height. Well, you do make right angles.
Mm-hmm. It's going to be perpendicular to the base.
Yeah. This will be 1/2. This will be 1. But therefore, this will, the length will have to be root 3 over 2. Right.
What do you think, Meg?
I was doing this at Pythagorean theorem, so I don't think that was right.
I think that's what he's doing. Or no, you're doing a Pythagorean triple. Right, you're saying one.
Yeah, wouldn't it work the same way?
I did the base was like Whole function minus the small function, or like the bigger function minus the little.
I think so. Yeah, I think on this one, the
And then,
upper y minus lower y.
so then I did that over 2, the base over 2, so that you could like find half of it.
Sure.
And then squared plus
And Pythagorean theorem.
5b squared equals
And what is that?
negative x plus 2.
Oh, negative x plus 2. Gotcha. Yeah.
Is that not right?
I think it's totally fine. I think that's looks very reasonable. I think some of the I think some of the details, mechanics of it in between are going to be they're going to be a little more challenging.
Yeah, no, I can't figure out how to get
Right, because now you got to solve for the thing you want,
it. Yeah.
and it's not impossible, but it's going to take
It's gonna be
more than I would want you to do. But I think your thoughts are intelligent for sure. I think you're approaching it well.
Yeah, this is.
Okay, but so that's
I don't even know if I would do it that way necessarily. I think there's lots of ways. I can think of 1, 2. I can think of maybe 3 or 4 ways you could approach this. I mean, we're all going to
okay.
kind of converge on the same spot at some point.
Yeah.
But yeah, why don't I show you a thought here, and then I'll give you an easy button as well. So I've got my picture up there of my solid, and then I took one of those little cross sections and I just drew it out separately so we could work with it, because to find the volume of this solid, it's going to be the integral. And maybe we should get this set up. Where would I start? No, let's actually go further back. Are these going to be, these little cross sections, are they going to be dx thick or dy thick? Right, they're perpendicular to the x, so they're dx. So it's going to be volume equals the integral of something dx. Okay, so then that means my accumulation has to follow x's as well. So guys, listen. For what x value would I start accumulating? 0. That's going to be this orange edge over here. So start at y or x equals 0, and I would stop accumulating at x equals 2 is right. There we go. And that would be this orange intersection point out there as well. Okay, so then really what it comes down to is how do we figure out the area formula? So maybe we start off here. Maybe you look at it and you just say, well, I know that the area of a triangle is 1/2 times base times height. But then what do I do with that, right? Because obviously every single one of these triangles is going to be different than the next one. So I've got to find a way to express this. And I would say of the base and the height, probably the base maybe would be the easier of the two. How would you guys express the base length?
Negative 1/2 x plus 1 minus 1/2 x minus 1.
And so you're basically taking the higher y minus the lower y?
Yeah.
Sure. Okay, so let's fill that in. So we'll get rid of the height. We'll just put that over here for now. So it's going to be times height, and then, oops, I will fill in my base length with what you said there, Meg. It's going to be negative 1/2 x plus 1. I'm running out of room. Minus, don't forget your parentheses, 1/2 x minus 1. And that's all times h times dx. So far, so good?
Mm-hmm.
So, maybe we clean this up a little bit and we say, all right, integral from 0 to 2, 1/2 times, this would be negative x plus 2 times height times dx. So now we got to handle the height. And how do we do that? Gosh, there's a couple different ways. I don't know. How about this? What if we said, and Meg, this is going to be a pretty close adaptation to something you suggested, except I'm going to do mine in terms of y to begin with.
Okay.
I don't know. So, you okay with this base length being 2y? Okay. No. So, isn't the distance from
X-axis and then
here
down below.
to here, isn't that a y distance? And so then wouldn't this be a mirror image of it? And I'm basing this on symmetry because this is a,
Symmetrical?
sorry?
Oh, it's equilateral.
Well, no, I would say that I'm actually referring more to the base being symmetrical across the x-axis, because the top line has a y-intercept of 1, the bottom line has a y-intercept of -1. The slope is... Then I think you have to go with exactly what Meg did. And maybe that's what I should do. I don't know. Do you want me just to do it that way in case of not symmetry? Would you be okay with that? Okay, let's do it in the case of there not being symmetry. So let's backtrack a little bit. So let me get rid of this 2y. So if we didn't recognize the symmetry, or maybe there was no symmetry, then wouldn't we have to say that this base length is -x plus 2? Okay, so that means the other two sides are also that. Got to find the height, though. So the height on an equilateral triangle, of course, would drop straight down from the vertex, and it would be perpendicular to the base. And so what you could have then is you could have a purple triangle that is half of that original. So that's supposed to be a right triangle. And it didn't want to be one. Oops. Let's just pretend like it's a right triangle. There we go. Okay. So then this would still be -x plus 2. This is unknown. That's our height. And wouldn't this be -x plus 2 all divided by 2?
Yeah.
It'd be half the original base. Okay. So then you could do like a Pythagorean triple, or like the 1√32 special triangle, or you could just do the Pythagorean theorem, right? Up to you. So you could go -x plus 2 squared is equal to h squared plus -x plus 2 all over 2 squared, right? Hypotenuse squared equals the sum of the legs squared. And then we'd have some algebra to do if we wanted to get that h all by itself. So it would be x squared minus 4x plus 4 equals h squared plus, I can just write it as 1/4 times -x squared minus 4x plus 4. Oops, it should be positive x squared. There we go. You could clear out that 4 by multiplying everything, that fourth by multiplying everything through by 4. So that would give you 4x squared minus 16x plus 16 equals 4h squared plus x squared minus 4x plus 4. Now we'd get some cancelings and various other pieces coming into play. I'll just come over here. So this would be 3x squared minus 12x.
Why is it 4h squared?
Because I multiplied everything through by 4. So every single term got a factor of 4.
You weren't distributing the 4, you were just getting rid of it.
I was getting rid of the 1/4 by distributing a 4 to everything. Sure, yeah. Let's see here. Plus 12 equals 4h squared. And then I would square root, or I would divide by 4, and then square root. So I'd get square root of 3x squared minus 12x plus 12, all divided by 2, if I square rooted the 4, equals h. Of course, there should be a plus or minus in there, but we know that we're dealing with a triangular area, so I don't think that would make a lot of sense, right? That we'd go with the negative version of altitude. So then what we would do then is replace that h with that. So Meg, that was kind of your question, right? You said, I kind of have this thing set up, what do I do? Basically it involves some, some algebra that's, got a lot of details you want to be really careful with, but I think that it's doable. It would certainly be at this stage, if we were going to actually find the volume, we would use Math 9 and do that.
So we just use like the 1, 1, 1.
Say again?
We
An equilateral triangle 1, 1, 1.
Like if you used each side as one, like what we were doing earlier.
I don't know. Let's talk about that. This would be one way to do it. Let me get rid of all the stuff that I've got there, and let's rethink what that would look like with a 1, 1, 1 concept. Okay, so you're saying, I just wanted to take what Meg said. That sounded interesting to me. So you said, could we make it a 1, 1, 1? So you're saying label all these sides with a 1.
Well, it's more like base that you're really labeling it with.
Well, if it's equilateral,
Yeah.
they're all 1s. Okay. So then you'd come down here and say this is 1, this is 1/2.
Yeah.
And so this is root 3 over 2.
Yes.
Right? It's just the 1 root 3, 2 scaled down by a factor of 2. Okay. And what'd you do?
The idea is that you're putting your height in terms of base. So
Mhm.
you kind of, the height is equal to root 3 over 2 base.
Okay. So h equals root 3 over 2 times base.
So you put that into your volume with the integral, saying
Yeah, okay.
that,
Yeah, so you're saying basically go integral from 0 to 2 of 1/2 base times root 3 over 2 times base.
Yeah.
Dx. Okay.
That's essentially what it works out to.
Yeah, so volume then equals, it would be b squared root 3 over 4 dx.
yeah.
Okay. So then you would, did you then figure out your base saying top, like red line minus blue line essentially?
Yeah, it was like x.
So negative x plus 2? Yeah.
So that would, because it's not like Dillon symmetry or anything, that would work in any equilateral triangle situation.
So this was going to be my easy button. So like the area formula for an equilateral triangle is side squared root 3 over 4.
Yeah.
So you could just, if you knew that, and you were faced with a situation, you just go side squared root 3 over 4, what's the side length, plug it in, and you're done. So then, this is going to be fun. So then, if you look at this, goodness, let me just pick this up. Oh, that's picking up more than I want. No, it's going to go right, I'm going to move that right over there. How about that? So this would, if we then, did what you said, it would be integral from 0 to 2 of negative x plus 2 squared root 3 over 4 dx, right? It's hard to see with that little thing there, but so what I was thinking is, oh wow, a lot of stuff moved that I didn't really want it to move, but that's okay. How on earth is that the same thing as what we have up above? And I think we can make it work. So if I were to take this, you all okay with 1/2 times 1/2 is 1/4? So it'd be 1/4 times negative x plus 2 times. So do you notice how inside that radicand, the 3x squared minus 12x plus 12, isn't there a common factor of 3?
Oh.
So it's square root of 3 times x minus, or excuse me, x squared minus 4x, how about? 4x plus 4. And so then do you see how that could be, we could separate the two pieces of the two factors in the radicand? So it'd be integral from 0 to 2 of 1/4 negative x plus 2 times root 3 times the square root of, now x squared minus 4x plus 4, isn't that x minus 2 squared? Okay, so then the square root of that would just be x minus 2. So then we look at that and we say, well, gosh, that seems different. But then maybe if you go back and realize that you could, instead of factoring this as x minus 2, you could actually factor it as 2 minus x. Ends up working out the same way. Oh, yeah.
Bless you, brother.
2 minus x times 2 minus x is 4 minus 2x minus 2x plus x squared. Right, it's the same thing. So then, when you realize that this square root cancels out with that squared, then this factor times this factor would just be negative x plus 2 quantity squared. We're in the exact same place as the green one. So Meg, I wanted to do that because I said at some point we're going to converge back to the same spot.
Yeah.
And it wasn't very obvious at that point.
Yeah, but now I see.
But now we can see that through, again, a little more algebra, carefully done, I think we can get back to the same place. So I think we've seen at least 3 options. Like Meg's option was, I want to put the base in terms of x right away. And some of the other ideas, like Nick's idea with the 1 root 3 2 thing, was I want to get the relationship between the base and the height set first, and then plug in the actual base length expression. Or, as Logan pointed out, if you know that that relationship works for all equilateral triangles, you could just use that. And you'd all get to the same place, and we could all debate about what's most efficient. But I think it's all lovely as long as everything you're doing is logical and making sense to you. You're kind of proving it to yourself that it all works together nicely, and that's a win for everybody. So it's great. Did anybody actually put this in the calculator and figure out what this number ends up being?
1.155.
1.155? Logan, you said you did this one before. Did you get that? Or did you not?
I didn't put it in the calculator.
You didn't run it through Math 9?
I don't wanna go.
Okay, so I'm guessing if and when Jack and or Santi watches this,
Sorry.
they'll tell us if 1.155 is indeed the numerical answer. You got what?
Oh, dang, I did that too.
8 over 3? So that's 2 and a third.
Yeah. So, wait, is that it?
So I'll put or
0.5x.
8 over 3.
No, I got 8 thirds when I worked it out.
No, I just totally did that.
Interesting.
I got 8 thirds when I worked it out on the computer. But I got calculator.
So if you do it, if you,
F of x minus g of x. Y minus y
Because I
c.
didn't multiply by root 3.
I was going to say, I don't think it can be 8 thirds because it's got to have a root 3 in it.
It is.
So you just need to multiply by root 3 over 4? Okay.
That's what I did.
So you know what? We'll just fix it. We'll just say 8 thirds times root 3 over 4. So when you, so let me ask you, Aiden, when you plugged that in your calculator, did you do Math 9 with the root 3 over 4 outside?
Yeah, I just didn't multiply by that.
Let me give you an encouragement here, and I'm saying this from experience. If you're ever going to use Math 9, type in that constant multiple first. Like pi Math 9, right? Like we talked about, or root 3 over 4 Math 9. Because it's so easy to get to the end and be like, hey, I did it, yay! And then, oh, I forgot.
Tried
It's easy to do. Okay.
for every Penn State loss.
So I feel like we have done what we needed to do with that one. No.
I'm gonna cry.
Yes, I would like to do 8 for sure.
8.
Number 8. Yeah, this is a really nice kind of cross unit
I know.
little example here. So it says the base of a certain solid is the region bounded by the coordinate axes, the line x equals 16, and the graph of y equals x to the negative 1/4 for the solid. Cross sections are squares, the perpendicular to the x-axis. Supposed to find the volume of the solid. I would suggest use your calculator and get just a quick look at what this graph looks like. Okay. I will attempt to sketch the same on my screen. Oh, I'm gonna.
wait.
Wait long.
Yeah, there's a potential for a wait moment here.
Hold on a minute. Mr. Anderson.
I know.
I see what you're doing.
Yeah, I
Yeah.
see it too.
Don't
I'm really
like
not
this.
happy.
And I don't like it. Oh, that's so
Really
sad.
gonna make me do this right now?
I think this is an awesome exercise. There's some great potential here.
Really?
You had to do this to us.
So are you guys okay with that being the region? And what's all your angst about? Why are you so concerned?
It goes up.
Yeah, it goes, yeah, there we go. It goes up. There's an asymptote, right?
Coaches.
So this is one of those scenarios where all of your cross sections, that are, right in here somewhere, like these are all pretty understandable. It's a square cross section. You got another one here. It's of course a little taller. But then you start to work your way over closer to that y-axis, and these cross sections get gigantic because as the closer you get to the y-axis, our red graph just goes up, 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 to quote Sam, and doesn't seem to have a point where it actually hits the y-axis, right? Guys, what are we talking about here? What's going to happen?
A limit.
We're going to have to use a limit
Which is
because
so rude.
the resulting integral. So if we were to try to set this integral up, we would say volume of this would be equal to the integral from, wouldn't it be from 0 to 16?
Yes.
Would accumulate from left to right. They would all be dx thick cross sections. And it's a square cross section. And so really, honestly, like the setting up the integral is not that bad, right? Because you just say, well, isn't it just sides squared? We're talking about squares, so it's sides squared. And what is the side length of each one of these squares? So let's break it down. Wouldn't the side length be this orange line that's probably a bad choice. Let's go with yellow. Can you see the yellow better?
Yeah.
So isn't that the side length of a square? Okay, so that side length, that's a y value, and it's going to vary depending on where we are in this region. But we wouldn't just write a y in there. We would say, well, y has to equal, y is really, in terms of x. Yeah, because the reason why I can't have a y in there is because they're dx cross sections. So I'd say, all right, well, y equals x to the negative 1/4. I'll clean this up just a little bit. And we say to ourselves, well, gosh, this is not that bad if I just, simplify. And by the way, how does that integrate and simplify? What's x to the negative 1/4 squared? Correct. We multiply those exponents. And this would be where you'd say, wow, this isn't going to be that bad, until you look at the graph and realize, well, this integral is not proper, right? It's an improper integral because this graph is not continuous on the closed interval from 0 to 16 because of the vertical asymptote. So to go back to what Peyton said a few minutes ago, we do have to use a limit. So I'd go volume equals the limit as x approaches 0 from which direction technically? From the right. That's actually pretty important. It should be a b. I'm going to go with b's because we already have x's that stand for the input variable. So b to 16, x to the negative 1/2. And now we're set up for success. We just need to get there. So do our antiderivative, and we get volume equals limit as b heads towards 0 from the right. This would be 2x to the 1/2, right? From b to 16. And then we just get busy plugging in, and it's not so bad. Limit is b approaches 0, and it would be 2, what's 16 to the 1/2? 2 times 4 minus 2b to the 1/2. And now we try to apply our limit. So as we approach 0, this is why from the right is super important, because if you approach 0 from the left, aren't you plugging in negative numbers technically? And we're square rooting them, so that would be a problem. But the fact that we're approaching 0 from the right means that we're plugging in positive numbers that are getting small towards 0, and so that actually works. So as we approach 0 from the right, what does 2b to the 1/2 do?
Goes to 0.
Heads towards 0. That's right. So we end up with 2 times 4 is 8. 8 minus 0 is 8. So this is one of those total conundrums of if the cross sections never stop, right? How is the volume finite? The answer is we use limits. Like limits allow us to actually see the pattern. We're looking at this pattern and saying, where is the volume headed? The volume is headed towards 8. So as we continue to add these little cross sections, these skinny ones, it would be, 7.9, 7.99, 7.999. You'd just be getting closer and closer to 8. You would never break through 8 and get to 8.2 or whatever. So anyways, so I thought that would be a nice thing for you guys to see because I care so much. Really want you to see some interesting things, some things that maybe make you think beyond just the, I have a procedure.
Wait, so
Anyways.
if as you approach the y-axis, the squares get infinitely
I
tall,
know.
does that mean that it has infinite perimeter but finite area?
We could, thanks for asking. Let's find the length of the red curve. You want to do that?
Sure.
All right, let's do it.
This is my cue.
So let's see here. So this is a totally different question, so I'm going to erase all this stuff. What a nice way to probably tie off our time together. Let's bring it back to arc length, right? Okay. So if I was going to find the arc length of the red curve, because we know that the x-axis length is finite for our region, right? We know that that little blue segment is finite length. It's really the red curve, right, that would determine, okay, how is this going to work as far as perimeter? And could it even really be a perimeter? Let's find out. So we'd say arc length equals integral from somewhere to somewhere. So I suggest we use x's. You okay with that? Okay, so it'll be square root of something dx. So it would be 1 plus the square, or not the square, the square of the derivative, right?
Yeah.
So it'd be negative 1/4 x to the negative 5/4 quantity squared. And then if we are using x's, what would be our accumulation interval?
From 0 to 16.
0 to, from x equals 0 to x equals 16. All right. So let's see here. How does this play out? First of all, it'd be limit as b approaches 0 from the right again. Integral from b to 16, square root of 1 plus 1/16 x to the negative 5/2.
You just know the casual x.
Say again?
You just know the casual x to the negative 5/2.
Right, no biggie, no biggie. Man,
All the time.
this is going to be,
Gross.
wow.
Gross.
I don't enjoy this one.
Wow.
This
Why
is a
would
math 9 situation.
But it doesn't work because
that's what I'm curious about. I don't know what's going to happen here. So,
Just do point
Just don't do it.
But that wouldn't be infinite and that wouldn't tell us exactly.
yeah, it wouldn't tell us exactly, but I don't know.
But wouldn't they give you a good approximation?
Yeah, we're going to be stuck here. We could,
Try it.
boy, this antiderivative, yuck. This is a really yucky antiderivative.
You have to have an
Gross.
X.
Say again?
outside.
Yeah, if there, we would need like
Let's just leave it. We know how to do it, so we just don't need to.
well, it's still interesting though. Like this is actual like real math. Like, what would you do if? ... Can we figure it out? You know, that kind of thing. Wow. To do this, we would need. If we're going to do this without technology, we would absolutely need an antiderivative of this.
No.
Off the top of my head, I don't know. I mean, we could probably. I don't know. You want to look on the antiderivative calculator?
Use symbol lab.
You can.
With that
It's
integral.
114.5 almost.
What is it?
Well, it's around 115 that you're gonna get.
And did you use like a bunch of zeros and then a 1? That's really, but I think Aiden's point is really important though, because
It's different, but it's not.
it's
but that's what it's
importantly
about.
different.
That's interesting.
Antiderivative, yeah, there's programs out there that they're not successful with every single one of them, but they'll give you an antiderivative. And Aiden is looking it up.
If I can actually type.
This is interesting though.
I think so. At its core, this like at its root, this is what math is. It's like we have a problem, we're not sure how to do it, so let's start problem solving and using as many resources as we can and trying things.
Symbol lab.
Symbol lab is so helpful, I tell ya.
Oh, just when you hit that like steps,
Oh yeah, hit that steps button.
and then you're like, oh, I just dropped a negative sign.
Yep.
That's all it was.
What's that? No, I'm just waiting. Aiden is. I don't want to lose my screen here. I have to lose my screen to search.
Functioning properly.
It's not functioning properly.
I should do this on my laptop.
Yeah.
Yeah, it'd be
Your phone's
easier.
old,
It'd
dang.
be easier for sure. But I mean, I think
Can you reach up to the top of the phone?
I think
turn it off?
the
My phone is old enough.
the exercise is useful in the sense of, hey, we reviewed some
That is
arc length, but I'm curious. I am kind of curious to know what the end result might be. There are definitely certain graphs where you will get like finite volume, but infinite surface area, and so your proposition might actually be.
Except they can all see each other.
I'm just gonna watch here. I'm just curious. So antiderivative of 1 plus I think so.
It's like, bro, stop.
Why do you care? Why do you want to know this?
Why?
Why what?
Yeah.
He broke Symbolab.
We broke symbol lab?
It says we don't know.
It's like, we don't know how to do this.
We're not sure. Hey, like I've told you guys before, I think I mentioned this. I don't remember which class I mentioned it. But there are way more integrands that people don't know the antiderivative of than those that do, right? And so some people's mathematical doctorate dissertation is about finding a method for an antiderivative to a certain type or certain group of functions. So maybe this is one of them. I don't know. Maybe this is one of them. But they're like, we think we know everything, but we definitely do not, right? So I wish there was a more satisfying answer here.
That's
I'll give you more hours.
I off the top,
I think the calculator would solve it if that is what we do it.
yeah, perhaps. Well, I'm just even speculating about what the arc length would be, or the perimeter, actually.
Yeah.
I suppose I don't know. We could make a table. We could kind of take Nick's approach. That's hard to decipher still, because like how many? I mean, you want to use a computer program, right? So you can get enough iterations and get zillions of zeros, right, instead of just 1,000 or something, for you to start to maybe decipher a pattern. But it's hard to decipher patterns like that are so. It's probably going to be really close. It's really hard to just look at the numbers and say, oh, well, duh. Sometimes it's not that obvious.
Yeah.
So, yeah, interesting. Thanks for asking. Okay. Guys have anything else as far as review questions? So let me just run through it really quick for you, just to make sure you can make mental little check marks here for your ladies, for your quest tomorrow. You've got area between curves. Okay, that was the kind of the first topic. You've got volume using disks, which is essentially integral of pi r squared, d whatever. Volume using washers, which is essentially a disc minus a smaller disc. Okay? You also have volume by cross sections, kind of like the couple we did today. And then you've also got length of a curve, which is what we just finished with. We didn't really finish with it, but we at least set it up, right? And maybe the integrand is not going to work, but okay. You okay with that? Okay. So I'll see you guys tomorrow. Have a good rest of your day.